Hello and welcome to another video. In this video we're going to be working on reduction operations to make the array elements equal. And so in this problem you're given an integer array nums and your goal is to make all elements in nums equal. To complete one operation, follow the steps, find the largest value in nums and find the next largest value in nums, strictly smaller, and you reduce nums to the second smallest or the second largest. And it doesn't really actually matter. Like they say, like if there's a tie, then pick the one with the smaller index or whatever, but you have to basically reduce all of them. So it doesn't really matter which one you pick first. So in this example, you have nums equals to 513. And so it takes all operations because essentially if we have 513, I'm going to write this in a sorted way to make it a little bit easier to see. Basically, you need to reduce the 5 to a 3 because you find the biggest element, then you reduce it to the second biggest element. So you reduce the 5 to a 3. And then you need to reduce everything else down to a 1 because the biggest element is 3, so the next biggest element is 1. So this is one operation, then we have 2 operations and 3 operations. And in the second example, everything's equal already. And now let's look at the third example. So we have 1, 1, 2, 2, 3. So first, what we need to do is find the biggest and reduce it to the second biggest. So we need to reduce 3 down to 2. That's one operation. And then we need to take every single 2 and reduce it down into a 1. So that's 3 more operations, so we have 4 total. So just to figure out like what algorithm to use, even though this one is kind of straightforward, we can look at the constraints, and we have 5 times 10 to the 4th. So something like dp on an n squared solution would probably fail. I think 10 to the 9th would fail. So you basically need an n log n or a O of n solution to make this pass. And so right away, the most common solutions are, for linear or something like that, are sliding window or 2-pointer or something like that. So maybe we could do something like that, or like a binary search. But let's kind of like figure out what we'd want to be using. So probably not DP, probably not something too complex, not any kind of brute force. We need like an n log n or n. So basically what we need to do is we need to take the biggest number and convert it into the second biggest number. And there's a few ways to do this, but the easiest way, first of all, like we want to know what the biggest number is quickly, right? Because we have to have a fast solution. So there's a few ways to do it, but just to also keep in mind that like if you have a bunch of the biggest number, you want them all ideally to be found right away. So there's 2 main ways of doing this problem. One is sorting, and one is getting a dictionary of numbers and then sorting those. But I think the dictionary of numbers is going to run a little bit faster on LeetCode, but it's going to take up space, and the O complexity will be actually worse because it's taking up space. Essentially, what we need to do is we need to basically sort our numbers. So let's just say we have a bunch of numbers, and I'll just draw out the sorted array right away. So let's say we have like 1, 1, 2, 4, 8, 12, 12, 12, 24 or something. So it's going to be very easy. Basically, what we're going to do is we're going to take our biggest number, and any number we find that is smaller, we're basically going to take everything that we've converted so far and convert all of that into the smaller number. And we can do this very quickly. So what we're going to do here is we're going to have like the result. We'll set equal to 0. And then we'll have another variable called like nums. We don't actually even need a variable. We can just use an index. So actually, if I take this array and instead of writing it like this, we could reverse it. So instead of reversing it, I'm just going to write the indices backwards, but essentially our array is going to be sorted top down. Actually, let's just rewrite it. So So instead of sorting this way, let's sort the other way. So we're going to have 24, 12, 12. And the index will tell us how many numbers we have very quickly. So instead of having another variable, you could have another variable as well. So let's say we have this. Now let's give all of these an index. So we'll say 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So basically what we're going to do is anytime we encounter a new number, that means we have to take everything before that and change it into that number. And I'm going to kind of show you how that looks like and updating our result. So in the beginning, we encountered a new number. So we're going to say, okay, whatever the index is of this number, we can figure out how many numbers come before this, right? So the index of the number is going to be the numbers that came before it. So we can write that down. So index equals numbers that came before it, right? So for like index 0, there are no numbers before it. For index 1, there's one number before it, and so on. And what basically we're going to say is we need to take everything and turn it into this number. And because it's sorted, we're automatically going to start at our biggest number and then turn it into the second biggest number, and so on. And you kind of see how this works. So we'll start at this first number. We'll say, okay, well, our result is going to add, so we need to take however numbers that came before this number, turn it into this number, and we can also initialize our current number. So we'll have another variable for like current number, call that like cur or something. We'll set it equal to null at first. So null. And essentially what we're going to say here is we're going to say, okay, we've reached the new number. So we're going to update our cur to be this new number. And we're going to take every single number before that and turn it into this number. And that's going to cost us n. Or it's going to cost us the number of numbers that came before it. So in this case, it's actually 0. So now let's go to the next number and you'll kind of see how this works. So now we've reached the new number. So we're going to say, okay, however many numbers came before this, they are all the same because we're going to be turning everything into the number we're currently on. So everything before the number we're currently on is all the same, and they're all bigger than this number, right? Because we've reached a new number. So we're going to say, okay, well, we have a 12, so we're going to update our cur to be 12. And we're going to say the number of operations we need to turn everything before this 12 into a 12 is however many numbers came before this. So in this case, there's only one number that came before this. So we'll update our result to 1. And this is basically saying we're going to turn our 24 into a 12, right? So we turn the 24 into a 12. And we can actually write it in here as well, just to make it easier to see. So essentially, that costs us one operation. Then we go to the next number and we say, is it the same or is it different? It's the same, so we can just keep going. You don't need to do any kind of modification. Here, it's the same. And here, it's different. So we're going to say we're guaranteed to have everything before this be some number, right? Because we are changing as we go. So how many operations, how many numbers are there? There are 4. So we're going to update this result to be 1 plus 4. And basically what we're saying is we're changing everything now into an 8. So our new cur is 8. And we're changing all of these numbers, right? Like I said, it doesn't really matter what index you pick first because you have to do all of them anyway. So it's basically irrelevant. So we're going to say 8, 8, 8. And 8 as well here. So now we have all 8s. Now we go to our new index. And kind of the same thing, right? So how many numbers do we have before this? Well, we have 5. So we'll add 5 here. And now we change all of these 8s into 4s. So 4, 4, 4, 4, 4. Update our current number to be 4. Go to the next index. Same thing, we have a new number. So we have 6 numbers we have to change. So 6, change everything into a 2. So change all of this into 2s. So 2, 2, 2, 2. 2. Now we come over here, same thing. We have a new number, update our number. How many numbers do we need to change? 7. So now we change everything into a 1. So I'm just going to cross this out and pretend these are all 1s now. And then when we get to 8, 8 is the same. So now everything is a 1, and it costs us this many operations. So we have 5 plus 5, 10 plus 13, 23. So that should be the return. So essentially, you just sort your numbers, and you go through, and you know that everything to the left of what you're at is already the same number. And every time you reach a new number, the number of changes you have to make is just the number of previous numbers before that. So it's going to be an n log n solution, pretty clean, not super hard to figure out. But yeah, we definitely did eliminate some things like DP and so on. So the first thing you want to look for typically is like, you know, do I need a SOR or can I have, ideally you want to have a solution where you can go through your array and you can traverse and you don't need to like cut out numbers, right? So if you can traverse in order, those are going to be the best solutions. So that's typically, and it's the most common one. So typically you want to look for like a sliding window if possible, and then if not, go to DP. And then after that, look for other stuff. So this is kind of, it's not a sliding window, it's just basically going element by element. Even easier than sliding window, right? So now we can code it up. And so what we're going to do is we're going to sort our numbers, but we're going to sort from biggest to smallest, right? Because we want to convert bigger numbers into smaller ones, and every time we reach a smaller one, we have to convert everything above that. So we're going to say nums.sort in reverse order. So you can just in Python do reverse equals true, and this will sort it in reverse order. Now we want to have a current number. We'll make that none, and we'll have a result equal to 0. And we'll just say like for I, v, and enumerate nums. If cur is new, right? So if cur does not equal v, then we update cur, so cur equals v. and we need to update our result. So every number before this number needs to get changed into this number. And how many numbers are there before this number? That's just going to be the index. So res plus equals I. And we can just return the result here. And hopefully that's it. So pretty easy one. I think that should be fine. And there we go. So we have a pretty efficient solution. Pretty straightforward. I think honestly this, I don't know if it's this whole month, but last few weeks the problems have been like really easy. I think the month before this we had like, it's crazy. They give you like a week of like almost all hard DP problems, and now they give you this kind of stuff. Kind of funny. But regardless, so the time complexity here is going to be n log n, right? Because we have a sort. Everything else, this is O of n, and the space is going to be O of 1. Now, like I said, you can, there is a thing that will actually run faster on LeetCode. And basically the idea there is instead of sorting, you would store key value pairs where the key is the number and the value is the count of the number. And then instead of sorting this, you can sort the keys, because then if you have a bunch of numbers that are the same, it will be faster. Also, I think something like a bucket sort would actually be faster for some situations, but for most of them it'll be slower. But this dictionary one is also worse in space because it has, it takes up space. So it'll be the same time complexity, it'll just have like a better runtime on LeetCode, which is like whatever. Yeah, so I think that's going to be all for this one though. So hopefully you like this one. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.